Welcome to part 2 of getting started with µFerris. In the first part, we went over the µFerris hardware and mounting instructions. Now we need to run software on the board. In this video, we'll go over the software setup, which entails two parts. The first part is setting up the toolchain. This is a one-time process that entails installing the tools required to compile code, generate project templates, and flash software to boards. The second part is running demos. This entails showing you how to run the µFerris-bsp board demos. One thing to note here is that we will be using the Xiao ESP32C3 board as a reference. Let's start by setting up the toolchain. In the first step, we need to install Rust and its tools. This command downloads and sets everything up. You can find this and all subsequent commands in the Getting Started document linked in the comments. Also, refer to the links in the comments if you are on a different operating system. After installing Rust, we need to add the build target for our chip. This is because we will be cross-compiling to a different target architecture than the one on the device on which we are writing code. The Xiao ESP32C3 has a RISC-V core. If you use a different Xiao with a different architecture, then you might need to change this line. Next, we need to install espflash. This is the tool that will flash our program onto the Xiao board. In case you are using a non-ESP board, then you would probably use a different tool like probe-rs. In the last step of the toolchain setup, we need to install espgenerate. espgenerate helps us create project templates for ESP devices. We'll start with a program that prints "Hello World" to the console. espgenerate creates this demo program by default when generating a project. We can flash it unmodified to our board for testing. This is a good check to make sure that our toolchain and connection are working. To generate a fresh project, use the shown espgenerate command. This command configures the project template completely from the command line. Alternatively, if you only type espgenerate, you get a menu of options to choose from. This would create a directory for the project in the folder path we are in. We are naming the project Hello µFerris. After the project generation is complete, we are ready to flash. Now you need to connect the Xiao to your laptop with a USB-C cable. You can confirm that the board has power if you see the red light in the lower right corner lit. After connecting the board, change directories to navigate to the Hello µFerris directory. In that directory, execute cargo run with the release option activated and monitor the output. After the board flashes, you will see "Hello World" being printed to the console output every 1 second. Let's make the board do something. We'll start with the classic, blinking an LED. We can use the µFerris board support package for that. Let's start by cloning the µFerris-bsp repository and step into it. After the repository is cloned, navigate into the Xiao board examples directory. This directory contains a collection of pre-written examples to run on the board. To flash the program, execute cargo run with the release option and the Blinky example application binary. There it is. The LED is blinking on the µFerris board. You can also run a full board demo. To do that, execute cargo run with the release option and the board demo application binary example. One thing to note, if you're using the power board, take the batteries out before flashing. With batteries inserted, flashing and serial communication can fail. You can leave the power board attached. Just pull the batteries while you flash and use the serial monitor, then put them back when you're running standalone. That's a full µFerris setup, from a fresh machine to a running demo. The Getting Started guide, the board support package, and the companion book are all linked in the comments below. If you're learning embedded Rust, that's the path to follow. Thanks for watching. Go build something.